Alright class, we're going to go ahead and do exercise 5 of the law of universal gravitation. It is saying, our galaxy, the Milky Way, contains approximately 4 times 10 to the 11th stars with an average mass of 2 times 10 to the 30 kilograms each. How far is the Milky Way from our nearest neighbor? So, how far is distance? That's what it's looking for. But this is still a law of universal gravitation problem. So we know we're going to need the equation. F equals G, mass 1, big mass, over distance squared. What are our givens in this problem? Given. What are we given? We know that the Milky Way contains 4 times 10 to the 11th stars, 4.0 times 10 to the 11th stars, and each of those has an average mass of 2 times 10 to the 30 kilograms. Andromeda contains roughly the same number of stars and attracts the Milky Way with a gravitational force of 2.4 times 10 to the 30 newtons. So we know F equals 2.4 times 10 to the 30 newtons. And so we're going to be rearranging this equation to solve for D, basically. Now, to do that, I'm going to go ahead and write solve for D. Solve for D. So a little bit of easy algebra here. Multiply both sides by D squared. So we're going to have D squared times F equals G M1 big M over D squared. And we're multiplying both sides by D squared to cancel. Got our D squared there. And now we got to get rid of that F. So I'm going to divide both sides. D squared times F divided by F equals G times M times big M. And we're dividing both sides by F. F's going to cancel on that side. And now we have to take the square root on both sides to get D by itself. Take the square root there, square root of all that. So the problem tells us that the mass of the Andromeda galaxy has pretty much the same number of stars, and we can assume that the average mass of them is the same. So for the Milky Way, call this Milky Way, has that many stars in it. Say Milky Way mass. And the Milky Way's mass is going to be that many stars by that much mass per star times 2.0 times 10 to the 30. I wonder if my calculator is going to even be able to do this problem. The numbers are so big. But anyway, plugging that in there. 4 10 to the 11th times 2 10 to the 30th equals 8 times 10 to the 41st power of kilograms of mass in the Milky Way. Now, basically this problem is telling us that these two galaxies pretty much have the same amount of mass, because it says Andromeda contains roughly the same number of stars. If it has roughly the same number of stars in it, then we can assume that their mass is roughly the same. So the Andromeda mass is equal to that also. And if we go ahead and plug those numbers into this formula that we solved, again, that formula will be D equals the square root of g times m times big M over f. Let's plug it in right here. The square root of g, which is 6.67 times 10 to the negative 11 Newton meter per kilogram squared, Newton meter squared per kilogram squared, excuse me, times the mass of one of them, which is 8 times 10 to the 41 kilograms, times the mass of the other one, which is 8 times 10 to the 41 kilograms, divided by, all divided by, and this square root sign is actually going to extend over the denominator too. The force, which was 2.4 times 10 to the 30 newtons. So these newtons are going to come up top and cancel those newtons. And the kilograms squared are going to cancel there. And then we're taking the square root of meters squared, which is going to give us meters. So we know we had this set up right. Let's go ahead and do the math. 6.67 shift 10 to the negative 11 times 8 shift 10 to the 41. 8 shift 10 to the 41 divided by 2.4 10 to the 30th, and we're going to have to take the square root of that. I'm getting 1.78 times 10 to the 43rd. Take the square root of the answer there, and I'm getting the distance equals 4.21 times 10 to the 21st meters. Just to see if that is the right answer, let's see how Google compares to what we got. I'm going to go ahead and Google how far is Andromeda from the Milky Way. 2.5 million light years. Let's do 2.5 million light years to meters. 2.5 million light years to meters. Google probably has a 2.36 times 10 to the 22nd. Interesting. Our answer is 4.21 times 10 to the 21st. I wonder if we're doing something wrong there, but I don't think so. Maybe they're just using some different parameters by which they're assessing the problem. Anyway, that's how I solved this problem.